Hi, Georgie. You have the floor.
Okay, thank you very much. Good afternoon, good morning, welcome everyone. This is the second breakout room of the session on strengthening the implementation of SDMX. Today we will have 4 speakers in the session. Each of them will have 15 minutes to present their case. Some of the presentations, as you will see, will be directly related to SDMX. Others will be related to a neighboring standard, VTL, and perhaps even on those cases, we will see the connections of that to SDMX and how they contribute to implementation efforts to SDMX. Feel free to put your questions to any of the participants in the question and answers section as we move along. The speakers will try to respond directly or take a few of your questions for the Q&A session, which will close our let's say, overall session today. So without further ado, I'm going to introduce our first speaker, Glenn Tice. Glenn is a computer scientist by profession. He spent 10 years at the BBC as IT director of one of their commercial units before moving to London's Transport Authority to sponsor technology projects and provide capital investment oversights on major road and rail infrastructure programs. In 2016, he joined Metadata Technology, a commercial company with a long association with SDMX, where he leads business development today. So, Glenn, the floor is yours.
Thank you, Georgie. Let me just quickly try and share my presentation. It should be there. Let me know if there is any problem seeing that. So yes, thank you very much indeed. So let me try and move to the next slide. There we go. So yes, so the presentation today is about making SDMX data more consumable, and we're not really talking here about websites or sort of graphical user interfaces or graphical discovery tools for casual users of those they have their place. This is about making it consumable for real data consumers, real organizations who want to use this part of their day-to-day operations. So we're going to share a couple of experiences that we have gathered over the period from trying to write tools for both consuming SDMX data and also for working with data consumer organizations, both in the official statistics space, so perhaps central banks that use it for their own research purposes, but also for external third-party organizations, perhaps like Bloomberg, organizations like that who are also regularly consuming data. So there are probably 2 key messages here, and the first is that in order to satisfy these needs of the serious data consumers, data publishers need to offer an API, and the reason for that is that serious data consumers want to automate their processes. So the data's got to be machine readable, and it's got to be accessible in an automated way. The second point here is that even though we're talking about providing an API, it doesn't need to be particularly sophisticated. There are lots and lots of very clever things that the SDMX API specification provides, and even more so in the SDMX3 specification. But it doesn't need to provide all of those. It only needs to provide a subset. We'll take a look at what those are later on in the presentation. So let's just start by looking at a representative case study. So this is something that we come across sort of relatively often, which is what we call the automated data pipeline, or some people call it a data portal. where data consumer organizations periodically, perhaps once a day or once a month or even once an hour, want to pull data sets into a local store, either for automated processing or perhaps for their own statisticians and economists to access. So there are sort of three stages in this, and the first stage is about dataset discovery. Really, what datasets do you have available? So it's going to be asking the API or the data service what datasets they are, effectively querying for a list of data flows. The second stage is about metadata retrieval. So the data consumer needs to know the structures. It needs to know the data structure definitions. It needs to know the code list. And it needs to know the concepts and the structural metadata that goes around the data in order to make sense of that. And then after they got the metadata, then the third stage here is actually retrieving the data itself into their data store. Now, this could be a complete data set. It could be a complete data flow, but often it is likely to be a subset of the data set, perhaps using some simple filters or some simple slicing. Now, often where users are pulling data on a regular basis, they're not going to want to re-pull the entire data set every time. So they may want to be asking for perhaps data that has been modified since a particular point in time. If perhaps they're pulling updates to a data set once a day, they may want to only receive data that has been modified since the last time they actually made the download. So that's the use case we're going to be looking at. So the point here is that the REST specification, as we say in 8th SDMX, does include a lot of sophistication, and particularly in SDMX3, you can provide predicates like in and contains and starts with, and some to construct some fairly sophisticated queries. The API does not need to support that for these sorts of use cases. There's also functions like pivoting. So there is a function in the REST API for specifying the so-called dimension at observation, which sets another dimension other than time. So you don't need to provide that either. A level of sophistication that's not needed here. But what they do need, though, is they do need access to the metadata, which is critical, and programmatic to access to the metadata via a structural API. The other point here is that you know, just basic simple filters suffice. So largely people are going to want to perhaps filter on frequency. They might want to filter on annual frequency. They might want to filter on reference area, but sophisticated structure queries are not actually needed in this particular case. But the key point here is that while providing perhaps data in downloadable SDMX formats is better than nothing, for most of these organizations, providing a file, even if it isn't SDMX format with the data, just is not particularly helpful for them, because it doesn't help them automate their processes. So in our experience,
recording in progress.
And we've selected sort of 4 of these, which are sort of based on our experience, just to sort of highlight to you today. The first of these is where the data service responds. The response is too large, and that may be because the data set is large, or there's some limits on the capacity of the server. Now, obviously, data services often need to protect themselves. So obviously, with very large data sets, it's difficult. Obviously, if a lot of consumers want to download large data sets concurrently, so there has to be some protections in place. So it's perfectly all right for data services, for data APIs to respond with, we're not going to support your query because the response is too large. But that's okay, provided that they provide some way to allow the client, to allow the data consumer to know how to construct a smaller query. And there are really two ways to do that. One is using the existing series keys only data query parameter, and the other one is the existing SDMX data availability API. And just to sort of put that into context here is a little bit of XML, which sort of shows the series keys only output, rather than providing observation data, just provides a list of what series are available. So data consumers can use that to get a sense of precisely what data is available without actually receiving the full data set. Similarly, with the data availability API, provides effectively a content constraint, so provides some information about what keys are available for each dimension. So another issue that we come across quite often is gateway timeout. So this is where the query takes too long to respond, and a client like a web browser or an automated data ingestion process receives a gateway timeout. So again, the solution is pretty much the same as for the previous problem. It's provide information which allows clients to create smaller queries. So provide information about what data is available, so clients can actually slice their query up into smaller chunks. So the third issue is bad metadata. So this is talking about structural metadata. This is about structures. So we pointed out earlier that in addition to providing users with an API to get the data, they have to be able to get the structural metadata as well in order to make sense of those. And there's a number of problems that we come across with those in terms of either web services which don't properly follow the SDMX standard, or other issues with it. But the real takeaway message here is again, it doesn't need to be complex. It's a minimum requirement, and that minimum requirement is just allowing users to retrieve the data flow and its descendants. So in other words, the data flow, information about the data flow, the data structure definition, the concepts, and the code list, and provide the API supports that, then that is sufficient. And the BAS's Fusion metadata registry product will provide a compliant API if needed. So the fourth and final issue I just wanted to highlight is what we call the Cartesian products, and this is a problem where the data server doesn't really have enough information itself about what data it has, so it tries to estimate it, and what it does is it comes up with it looks at all the various dimension values which are available in the DSD, and tries to calculate how many series there may be for a particular data set. So that isn't particularly helpful because it basically provides consumers with misinformation about the size of the data and number of series that are available. And so as we're sort of showing on the slide there, that number with lots of zeros. So if you take this to the extreme, the balance of payments or balance of payments data set, if you calculate all the possible series that could be under the balance of payments data set, it comes out with a very big number, which isn't particularly helpful to people who want to automate their services. So the point there is if data APIs be provided, then the service which understands what data it really has and can provide the information to data consumers is the thing to do there. So just to close then, to make SDMX data more consumable, there's really sort of four things we recommend in summary. Offer a web service API which allows consumers to automate their data harvesting processes. Make sure that includes an SDMX compliant structure API as well, so they can get the structures and the metadata that they need. Again, it doesn't need to be complex, just the data flow and the descendants is sufficient. The data API doesn't need to support all the bells and whistles of the specification, so simple filters and perhaps the updated after function is sufficient there to allow data consumers to produce incremental updates. but consumers must be able to find out what data they have available. So supporting the series keys only, or perhaps the availability API will really help them, because it allows them to find out precisely what data is available and tune their queries accordingly. That's all. Thank you.
Thank you, Glenn, for this very interesting presentation. For the participants, I'm suggesting that please put your questions into the Q&A box that you would like to ask from Glenn. And in the meantime, we move ahead to the next presentation. This presentation will be delivered by Anastasia Samsonova, who is a senior systems analyst at Helmes, Estonia. Currently, she is doing consultancy work for the OECD Smart Data Practices team as part of OECD's SDMX remodeling and migration to the .StatSuite platform project. She is also doing modeling support for the Statistical Information System Collaboration Community members. And she is an SDMX practitioner since 2016. So, Anastasia, the floor is yours.
Thank you, Yuri. I hope you can see my screen and can hear me well.
Yes.
Great. Good morning, good afternoon, or good evening, everyone. It's a great honor for me to be here to speak to you today. My presentation will be about the modeling of units of measure and how SDMX features, for example, SDMX annotations, make the end user experience in data dissemination platforms like .StatSuite easier. To start with, the units of measure modeling is quite a complicated task, and it's been quite hard to harmonize it. In OECD, we have started a working group that is discussing different questions that are related to units of measure modeling and how to present units of measure in the dissemination table. We are working on providing guidelines on how to do this, and in my presentation, I will share some ideas that we are trying to follow in this and how we can achieve this with SDMX features. So in general, we take a lot of inspiration from science analogies, and in our data models, we try to classify dimensions and attributes into 3 groups. The first one is object the data is about, and then the property that is being measured, and the third one is the measurement standard, or how the property is being measured. And we pay a lot of attention to make sure that all these 3 things, when combined together, read well. As you can see here in an example on the screen, for example, sun could be an object, and its property that is being measured is average distance from Earth, and it could equal to 149.6 million kilometers. That would be unit of measure. This is kind of a simplified example. In real life, in social or economic statistics, the unit of measure might not be that simple, and we might need to introduce different components of units of measure in its composition. Like, for example, as you can see here, the unit of measure could consist of just one component, which is the unit of measure itself. But additionally, what we might need to introduce the unit multipliers into the unit of measure, which in this case is US dollars, millions. When we talk about indices, we might need to add a base period to the unit of measure definition, like you can see here, US dollars since 2015. We might also need to distinguish current prices or constant prices in the unit of measure definition. So it means that we need to add additional components for prices into the unit of measure. And when talking about very complex examples, the like we have in the example here below, we might need to include 6 or 8 different components in the unit of measure. In the example here, we have the transformation, the unit multiplier, unit of measure, which is currency, and then prices and base year and adjustment. Now, that's the question, how to model all those things in SDMX, and how to present those things to the end users. So when talking about data modeling, we try to follow the pure modeling approach, meaning that we create as many atomic dimensions and attributes as needed, so we don't combine the components of the unit of measure into one long label, or try to duplicate some things into some of the components, and also avoid mixing the concepts. So this means that if we say that unit of measure consists of unit of measure, unit multiplier, base periods, prices, and maybe something else, then we create separate dimensions or attributes in the data model for those. And for the data presentation, we can use the SDMX annotations and define there the broad unit of measure composition. And so why we can do it, recently a guidelines document for the SDMX annotation has been published on the sdmx.org website, and it defines different standard SDMX types of annotations that could be used to provide some additional details in addition to the structural metadata that we have in DSDs and call lists and so on. We can attach some additional information that can be used by other systems to process this data. So in case of units of measure, there are 2 types of standard annotations that can be used and that help the systems to process this information. The first type is unit measure concept. This is a list of concepts which is comma separated, where you define what is the broad composition of the unit of measure. In example here, we have the units measure, units multiply, and adjust. And we say that the composition of a unit of measure in this case. And the second type of annotation that can be used is unit measure label. This is additional annotation where you can say that I don't want the system to generate the labels automatically, just concatenate the labels of dimensions and attributes that I provide. I would like to define my own composite units of measure and store them in separate attributes. And in this annotation, I just say that take the labels from this attribute. I will show this later in the example, how this can be done. But first, perhaps let's take a look at a simpler example, where this is a screenshot from the DOSStat suite, where you can see we have the units of measure column, and it has a composite unit of measure in it. But actually, this is not how we defined it in the data model. This is how the system generates the complex unit of measure here. So we have here euros or US dollars. This is the unit of measure, dimensional attribute in our model. And then we have millions, which is a unit multiply in our data model. And we have the base periods that is also a separate attribute. In DOSStat suite, how you can achieve this behavior, you either provide the annotation as I described previously, you write unit measure concepts, and this will be concatenated by default. Or DOSStat suite can be configured to automatically generate the labels of some standards of the unit of measure. For example, if we say that unit measure, unit multiply, and base period are always components of the unit of measure, then you can configure the stat suite and it will be generated automatically on the fly. Or if you would like to have a different composition, if you would like to add more components to your unit of measure, then on a DSD or on a data flow level, you can attach an annotation with the type unit measure concept and say, this is the composition that I would like to have for this concrete data flow or DSD. So let's move to another example, a more complex one. Again, it was generated with the help of unit measure concepts annotation. And it's based on the national accounts DSD, which is quite complex. And here we decided that unit of measure would consist of more concepts than in the previous example. And in the annotation, we said that it would be transformation, which is put here as non-transformed data, unit multiplier, which is millions, unit measure, which is euro, prices, which is chain linked volume or current prices, reference year price, and adjustment. So this is how it generates in the table, but all these components actually separate dimensions to attributes in the structure. And that means that if you would like to filter, for example, for transformation or adjustment, then it's possible, and you still would have the filters of your table. But all the information that is related to the unit of measure will be displayed together so that the user doesn't have to search for it everywhere in the table. And this is quite useful. And additionally, with some not displayed annotations, you can also say that I don't want to show some text that don't provide some additional information like non-transformed data. I don't want to see it here. Please keep it. And you can say I don't want to see only. I don't want to see not adjusted data. I would like to see any other different values. So in combination with the not displayed annotation, also configure a bit the outputs of this concatenation. But if the data owner thinks that this generated automatically text is not good enough for the end users, then, as I mentioned before, that there is another way to say to store the refined labels for this composite unit of measure in the attributes. You add additional attributes in your data model. In this example, we call it UOM_attribute. And we say that please take the labels from this attribute. Of course, it provides a better user experience, but it also means that it needs some additional maintenance, and data owner needs to provide all those labels themselves in the attribute that is added to the structure. So, yeah, to summarize, we think that SDMX annotations is a very powerful tool where we can store a lot of different information that can be processed by other systems, and using those annotations like unit measure concepts, unit measure label, not displayed, or as Jens today showed for layouts in rows, columns, row sections, and so on. When we provide this information in annotations, it really helps to achieve a better end user experience in the dissemination tables. That's it from my side. Thank you very much for your attention, and I'm happy to answer questions in the QA session if there will be any.
Thank you, Anastasia. I think you already have a few questions. I can see them in the Q&A, so feel free to answer them directly in the chat or take some of them that you think are worth explaining later on in the Q&A section. So we are moving now to the second part of the session, which will mostly be concerned with VTL implementations and VTL cases. So the next speaker is Antonio Ojeros. Let me introduce him as well before he starts speaking. So he is the founder and CEO of Meaningful Data, a company providing software and consulting services on official statistics and regulatory reporting. Prior to the foundation of Meaningful Data, Antonio has been working for over 12 years in the regulatory reporting area of Banco de España and the European Central Bank, working extensively with data collected in XBRL and SDMX formats. In the ECB, Antonio led and coordinated the team that started and developed the single data dictionary and the bank's integrated reporting dictionary, BIRD. Antonio also holds a master's degree in law and in economics from the Carlos III University in Madrid. Antonio, the floor is yours.
Want to confirm. Okay. So, well, hello to everybody. I'm also very pleased to be here in this conference doing this presentation on VTL and the VTL suite. So I think that this presentation fits very well into this session because I think that VTL is going to be strengthening the SDMX, the SDMX process itself. So the thing is that so far, I mean, the SDMX is used in order to be able to deal with the statistical processes, right? And in the end, in the statistical processes, you have a lot of validations and transformation. But so far, with the current SDMX, you don't have a lot of artifacts to define these things. There are some things like mappings and some other things that one can do, but there are not specific artifacts in order to create validation and transformation. And this is what VTL is bringing in. And I think that this option of writing validation and transformations is key in order to have SDMX implementations that are good for the full statistical process. So with the presentation, I intend to do two things. First, I want to try to convince you that VTL is the right standard for you to use in order to describe your validations and transformations. And second, I want to demonstrate you a bit our VTL suite in order to show you how this VTL suite can support your organization with using VTL. As you can imagine, with 15 minutes is not a lot of time. It's going to be quite challenging. So the first thing I don't want to do is to devote too much time talking about meaningful data. So I just want to tell you that we are a software developing company. We also provide advisory services, always on the fields of official statistics and regulatory reporting. And I don't want to let this opportunity pass. I would like to show you something else we are developing related to SDMX. We are building this open source library for SDMX in Python that is called SDMX. You can check it out. It's not the subject of the presentation today, but I just wanted to take advantage and to just to mention that it exists. So coming with the presentation, I wanted to start with a short introduction about VTL, what VTL is. And in order to do that, I'm just going to take this description that is taken directly from the VTL specification documentation, because I think it is very good because it is covering everything that it has to cover. So this definition says that VTL is a standard that is defined under the umbrella of the SDMX governance. The purpose of VTL is to allow a formal and standard definition of algorithms to validate statistical data and calculate derived data. So I think there are three key aspects here. First, we are talking about a standard. Second is allowing formal descriptions of validation and transformations. And third, it is good not only for validations, but also for calculating the derived data. But the thing is that, I mean, if you only see this definition, you can say, okay, but SQL, for instance, fits also perfectly well in this definition. So why should I use VTL instead of SQL? For me, the answer comes with the VTL requirements, the VTL use cases. So if you go to the VTL documentation, they have, I think, to remember around 8 business requirements. But I'd like to summarize the two most important requirements from my perspective is that VTL should be business friendly and executable. What do I mean by this? So normally I mean, there is a trade-off here, right? So we can go more to the executable side or to the business-friendly side. So if we take SQL, for instance, SQL is executable, and some people may say that, okay, SQL is simple. Well, SQL is simple for IT people, and sometimes, because if you have to do some queries, for instance, to validate that some time series, the time series for the European Union, for instance, equals the sum of the time series of each of the countries, writing that query in SQL can be very challenging. And understanding that query can be very challenging as well. So I think that is not very business user friendly, at least for the use cases that we find here, right? On the other extreme, we find what I have found usually in my career, which is the stream where business users, what they do is they open an Excel or they open a Word file and they start writing the validations in transformations in some kind of pseudocode, right? So it is something that is not formal, but it allows them to understand themselves among themselves. And then they have to give this to an IT person that needs to be able to read this, understand it, and do some interpretations without having business knowledge in order to do an IT implementation. And as you can imagine, this is not very effective. So what VTL is trying to do is to find a good balance so that the VTL can be written by business users, can be understood by business users, because it is very important for VTL that it is meant to be shared with other stakeholders, right? And it has to be executable so that you don't depend later on someone from IT implementing it in a different language. So how does VTL fit into the statistical process? If we take the normal picture of the statistical process with the collection, production, and dissemination phases, I mean, if we go to the collection phase, the most relevant thing is the validation. And I think this is one of the issues we all have faced when we have been collecting data. We have to validate data and we have to see how to validate it. Then if we go to the production, what I wanted to tell you here is that VTL is very powerful. So we are writing a lot of VTL and we have seen that it is very complete. You can do a lot of things. Here I have some examples of typical things that one can do in production, like plausibility checks or outlier detections. You can do aggregations. You can do integration, meaning that you take different data sets from different data sources and you derive data based on the combination of these different data sources. And you can even write very complex ETL processes. You may be familiar with the ECB's project, BERT, the Banks Integrated Reporting Dictionary. They are using VTL, and then basically what they are doing is they are writing a huge ETL process, and it is fully written in VTL. But having VTL is not enough. If you want to have a successful implementation in your organization, I think you need to add something more, some tools. In my opinion, the most relevant things are here. So first, you need to facilitate the creation of transformation schemes. Transformation schemes are VTL scripts, basically. Okay. What happens that, at least in my experience, many of these projects, they take a long time and they evolve over time. And there are a lot of users collaborating. So you have to make that process simple, right? So you need to enable collaboration so that several users can work at the same time on the same project, right? You need to have some auditing so that 3 years later, when someone asks, okay, but why did we delete this? We can go back and see who deleted it, when, and why. Hopefully there will be a reason there, right? We need versioning because we need to know at each point of time what is exactly the version of the VTL script that we have. And we need some governance as well, because this VTL is going to production. So you don't want that everyone in the organization is able to write some VTL code so that they can break something, right? So this is the first thing, facilitating solely the creation, so writing VTL. The second thing is automation, because first, of course, you don't want your user, so a physical person, clicking a button each time a file with data comes in order to validate it, right? So you need an API to integrate your VTL implementation with other systems. But also, very importantly, you need a good task manager, because at least in my experience, if you have some filers and they have like 10 days to report their filings, most likely 90% of them would report the 10th day close of business. So it is very likely that you are going to see yourself in a situation where you are receiving a lot of data at the same time, and you have to be able to deal with these concurrent requests, right? And finally, you need to have an effective way of sharing the transformation schemes with stakeholders. Because as I said before, one of the characteristics of VTL is that they are shared with external stakeholders. And VTL itself can look like a bit of a scripting language, can be a bit cryptic for some business users. But it is very easy to create some Excels or some other kinds of reports that is purely VTL, so it is 100% VTL, but that are providing some tools for the users to be able to navigate and to understand better the VTL. So coming already to our tool, the VTL suite, we have designed this tool with those requirements that I have shown you in last slide. So first of all, we have a web application that is providing a graphical user interface and several tools for the users to create the VTL script. As I said before, of these issues with collaboration, auditing, versioning, and so on, and also the governance. Basically, only some specific users, whenever some requirements are met, can decide that this VTL, this version of VTL is moving to production, right? So this would be the second phase. Then we have the task manager, what we call the VTL manager. This VTL manager is providing the API for automation, right? So that it is a web REST service, so that any other application or even some humans can do a request to execute some VTL script that you have already in production, okay? And behind the scenes, we have always the VTL engine. So now I would like to very, very quickly, because we don't have a lot of time, show you something about the tool and mainly about the VTL in order for you to see some real cases of VTL. So this is the VTL playground. Okay, basically here I just wanted to show you that, okay, this is a web application where we have some organization by users, and we have projects and groups of users. We have the audit, so we are able to see what user has done when. So for instance, in this case, the user demo has modified this library item in this date, right? And the user, when doing the modification, may have left a message explaining what this modification is about, right? We are also able to deal with versions. So for this example, I create 2 different versions, right, with their own validity dates, and where we can see for each object what is the status, okay? But we can move forward to what is the actual VTL. I wanted to show you some very simple examples. First, an example of validation. And the most typical validations that we are going to be able to find are what are called hierarchical rule sets and data point rule sets. These hierarchical rule sets, I'm going to enlarge a bit the screen. Basically, what they do is establish relationships between codes of a code list. Okay, so in this case, we have a code list of counterparty sectors. This, by the way, I took the business locational statistics data set as an example, right? And here we have that there is this code that is total banks, no banks, and unallocated. So then the business users can write something like this, and this is the expression with the validation in VTL, okay? Then the validations can have also identifiers, and they can have other things like error codes and error label. Then in the validation, we just can call this artifact, this hierarchical rule set, it's a sectors hierarchy that we saw here, and we can say, okay, apply this to this log stats dataset. Okay, very similar. We have the data point rule sets. The data point rule sets, they they express validations between different components, different fields on the same data set. In this case, it was a kind of sign validation. So depending on the values of two components, in this case, the position and the measure, we can say that the observation value has to be greater or equal to 0, meaning it cannot be negative, okay? So I don't want to go much behind time. So just to tell you that we are able to do much more complex things with VTL. So this is an example of one plausibility checks that is already quite complex, because here you are able to check, to compare the data points with the average of for the same time series, the average of the previous period. And in this case, for instance, we are comparing things that are, it has to be between 80 and 120%. Just to tell you that this can become easily more complex because you are able to create graphs. I mean, you are able to compose transformations. In this case, we do a first transformation that then the result acts as input of the second transformation, okay? And well, and because we are right with time, I wanted to show you also some other features of the tool, like you are able to run things and see exactly what the results have been. We are able to compare versions, see the history, the different versions that we have for the same thing, okay? But at this time, I'm going to stop with this just because I don't want to take time from the following presentations. So coming back to the slides, just thank you for your attention, but I wanted to raise this because recently we created what is called the Vtl Community. It's a community of people and institutions that are related to VTL, and we are exchanging concerns and well, ideas about what to do with VTL. And I think it is quite interesting. So if you are interested in developing or using VTL, I really encourage you to go here and to check what this VTL community is about. So thank you very much.
Thank you, Antonio. This was an interesting presentation. I think questions have started to appear for your presentation already in the Q&A section. So you can go and start the responses or prepare for the live Q&A session. In the meantime, I'm going to introduce our next and final speaker, Katrin Heinzer from the ECB. Is also going to present a VTL case using VTL as a self-service in the cloud. So Katrin works since February 2014 at the European Central Bank. She is a team lead and she works as a business analyst in a project responsible for the evolution of the central data collection platform of the ECB. Before she joined the ECB, she worked as a software developer and project manager at the German Central Bank. She was part of the core team for the definition of the European data format and related metadata model for the harmonized framework for prudential reporting. Katrin coordinates an initiative to identify and evaluate generic services that can be offered in a future data services marketplace to be made available in the cloud in a data-centric as well as service-oriented IT reference architecture. Katrin holds a bachelor's degree in business administration from the University of Applied Sciences of the German Central Bank and a master's degree in business informatics from the University of Bamberg, Germany. Katrin, the floor is yours.
Thank you, Gregory, for the nice introduction. And hello from my side. I'm quite glad that Antonio gave such a good introduction into VTL, because I do not touch this topic from the basic point of view. It's more, I'd like to introduce you to my fifth validation and calculation in my business life. I was responsible for designing, developing, and the usage of such calculation and validation platforms. And it was needed to support the data quality management for data collected by central banks. So not only the ECB, but also the Bundesbank as German central bank. Why do we need yet another engine? Yes. What difference brings this engine that I would like to present, and its name is VALIS, compared to the other engines that might be still in use? So first of all, VTL is independent of a specific data format. This brings really added value. data can be accessed by this engine from various data sources. The language is standardized or will be standardized hopefully soon with a moving SDMX standard. It is based on a generic and simple information model, and we have already a good availability of open source software. Antonio already mentioned the Vtl community, in which you get more information about this. Yeah, you see Vtl offers already a good bundle of advantages, the same for this engine, but there's more to say. So we have a lot of business users who work on Hadoop, and they use Hadoop as a self-service. They can do data integration with Hadoop, they can do good data analytics, but for data quality checks or calculations on a larger scales and across data sets, it's quite tedious to program. They want to have it automated and daily refreshed. All these repetitive tasks to do manually as self-service is not really manageable. So this is why we have now, why a lot of different solutions exist. So business users who have the need to collect data, they save it in a data lake, but then they have to quality check it. They use the standard toolset that is offered by the ECB, in our case Tableau, the UE platform for queries, Excel, R, Python, so a variety of tools. And if they find issues, they inform the reporters via email. And if you are glad and there's not too much software behind, you can easily manage changes on calculations, validations. But if there are thousands of calculations, which is the case for microdata, or hundreds of validations, which is also the case for many data sets, then it's a bit tedious to do it manually, so you need IT support. But as it takes sometimes several months to get the new release done, you need also self-service to do the revisions of validation rules, calculations in a timely manner. So what we have proposed, you already know the requirements of Vtl engine, and we have also implemented something like this, but on a very minimal viable product at this point in time. So we work with everything what we have already. In this case, we have the self-service provided by Hadoop, where we can use SQL to define the data we would like to work upon. So we are not working on SDMX as such, we are working on any data that is accessible via Hadoop at the current point in time. So the user defines the SQLs, and if the results can be downloaded as CSV files, for example. This CSV files, they can build the basis to define Vtl scripts. So here, this is the Vtl Studio provided by Banca d'Italia as open source software, where you can say, load my CSV file, and then you write Vtl scripts. You see there's also syntax highlighting here, quite good support. It's possible to compile the scripts, and then you have a Dataset Explorer that allows you to go in each and every dataset and see how it results in a nice tabular fashion. You have also a Graph Explorer that shows the dependencies between the datasets. And if you are happy with the results of your Vtl script, you continue with this and save it in our management area, which is also an open source and very simple front end. It's our GitLab version in the cloud. So we offer our users to use this GitLab for normal IT work. We use it, but also for business users. So they can use GitLab to version their machine learning stuff or just simple Python codes. We have a lot of APIs that support them in a different work. So everything can be managed here. So also collaboration, versioning is supported. So everything that we know as software developer, which is nice to work on Vtl or on scripts or on source code, is offered by this for free. And this is also the front end for users in Valis. For the backend, so to reach really the execution of Vtl scripts, we offer a REST API. And with the help of these GitLab, IT changes on validations like Vtl scripts or changes on the underlying data can be done as self-service without any IT change. How is Vtl now embedded into the ECB business process? You saw already the process in Antonio's presentation. Here I've extended it a bit from the central bank side. We have a central data collection system which offers users a front end in which they can upload files, so nice little front end for internet and also ESCB usage. And if there's more A to A, they can use a shared service. It's a managed file transfer. And we try to bring as soon as possible our data into the data lake. And here Vtl starts. So we can do data validation across data sets stored in the data lake. We can create calculations, transformations, and using the variety of data that is available here in Hadoop. Afterwards, we have the results, and we have the results in the data lake, and we can either share via the data lake the results, especially from transformations or calculations, but they can be also published via our statistical data warehouse, the ECB data portal, which is the name in the future, or we publish to the ECB website, or we just produce data that can be shared easily with national central banks or national central authorities. And you might need or want to know how it works in detail. As I stated already, we have this front end for users, which is our remote GitLab. And we have our API for application usage, or just use your laptop as the user and run the API call. This is a post call because it starts an asynchronous process. The data is fetched, and this is fetched via the config service from the local GitLab. So we have a constant synchronization between the remote GitLab and the local GitLab to ensure during maintenance phases of the remote GitLab that the sources are always available. Then we transform the information, the data, into the information model requested by Vtl. So we have also somehow a little extension where we can also transform microdata in key value pairs. It's stored mainly into a structure that is more column-based as requested by this information model. And this is done, and we work on CSV files. Like you know it already from the editor, it can load CSV files, and in our case, we work also on CSV files. Then we fetch this Vtl. This is a configuration file that combines the data with the Vtl scripts, and this is also called from the config service, local GitLab, and then we bring both together to the Vtl engine. Behind this Vtl engine, we work with the open source software from Banca d'Italia. Yeah, you will see the link with the Vtl community at the end of the presentation, where you can also retrieve it. It has a very good coverage of 98 or 99% of the standard. So it's really good. We offered also a quite good test set in the meantime when we worked on Vtl. So I would say it reached a very good stability. Currently, it's a minimal viable product. So we still work with an H2 database, which will be soon replaced by an Oracle database. As soon as the Vtl is executed and the data set is produced, we save the results in Hadoop and in the data lake, so to say. So it's accessible again by the users to work directly with the data, either create new tables out of it and so on. Yeah, more to say, currently it is working on a virtual machine on Windows basis, but we are now prepared to move everything to the cloud. Everything has been developed in such a case that it can be run in a Docker container, and this will be the next step. We will move this validation engine to the cloud to be able to scale it up easily. What are the business benefits, so to say, for our users? So due to the self-service capabilities of Vtl, we offer a short time to market. So with very low development costs, we have established Vtl because we're using open source software. We use a front end that already exists. It's GitLab. If we need to train the people in Vtl, we also see some hiccups here because often we have syntaxes which are more easy to use. So we are thinking about hiding this complexity sometimes for very easy validation rules and do the VTL preparation in the backend. For example, if you have to check if A is equal to B, it is an easy VTL also, but if you have a bit more syntax, then it's quite easy to hide the complexity for business users. This might be another front end for users that have less experience with VTL, but more experience with Excel. There are similarities if you go not into the scripting language. So I would say, yes, it's easy to learn. Velis has also this IT support, so it provides reliability and stability for the users. It's cloud prepared, so we offer also a good scalability in the future. As I already stated, the Banca d'Italia open source software offers a large variety of VTL functions already. And with the capability to combine the Impala SQL queries with VTL, yeah, it's quite easy to come to the result that you would like to see. Either you're more experienced with SQL or VTL, and combined with this, you even have a larger extent of capabilities. The open source software from Banca d'Italia offers also integration with public SDMX web services. So within the scripts, you can reference a web service, and then you can deal with this data at the same time. This is the only reference to SDMX in my presentation because we are really agnostic to any data format. So whatever data is collected in Excel, in CSV, in XML, we put it into the data lake. And from there, we start to bring this the data into the generic information model, and then we start with VTL. So I hope that we don't need to create a 6 validation engine on top, and can use VTL on big data also in the future, would be really, really appreciated. And the development is going into this direction. You see it also in this community, that there are new initiatives moving VTL to Spark and offering even more capabilities with the big data technologies. We also envisage to integrate with the metadata repository. With SDMX, it comes together with metadata, which is quite convenient. In our case, we have to add it. So we have to add in the configuration files, what is the column data type that we retrieve? And to ease this definition and have it out of the box, we would like to combine Velis with a metadata repository to have it even more generic. In our case, we combine Velis with Camunda, our workflow engine, to really digitalize the business process. So collect data from the centralized collection platform, bring the data into this, run Velis for validations, start additional Spark jobs to enrich data, and so on until the process is finalized. And this is the full embedded thing. And we would like to offer this as data service in our marketplace. Currently, it's an MVP. We start with the first business processes, but the idea is really to make it productive for larger use in the ECB. That would be my presentation. Many thanks for listening and for your attention.
Yeah, thank you, Catherine. I think we have reached the end of the presentations. So now we can turn to a Q&A session. We have roughly 12 minutes left from the overall session. So I propose that we go and try to address questions in the same order as we had the presentations. I saw that Glenn had answered already some of the questions that were addressed to him. Perhaps I also have one that I could add to it. I don't know whether you can take it on the fly, Glenn. It's I was wondering that your example was related to the SDMX ML flavor of the web service. Would you say that for catering for different type of uses, the web service should be complete in one flavor, or all the different flavors could cater to different type of applications, and perhaps some of them are more strong in the structural part, and some others are less strong in it, and focus on data delivery in a different way.
Yes, the SDMXML I provided because it's probably the easier to read, particularly for the structural queries. But equally well, obviously for structured queries, the JSON works well as well. Obviously, the JSON structure messages very closely mirror what the XML is. So I think it really should be largely format agnostic. Sophisticated data consumers will generally be happy working with either the XML or the JSON or even the CSV as such. And obviously the availability of the connectors, particularly the connector projects from the Bank of Italia, provide very good functionality for that. So it's although I use XML in the presentations, it was really only for illustrative purposes, and I don't think it should be limited to XML at all.
Okay. Would you like to bring up the question you had in the written section?
Yes, certainly. So Abdullah, let me just remind everyone. So Abdullah from the UN asked about what about dealing, or what was the advice for dealing with sparse cubes? So we understand that this is being data sets for which there are a few observations within the number of possible observations set by the dimensions. And I think if I understand his question correctly, probably the answer there is, as is sort of outlined in the presentation, either the data availability API or even this series keys only option on the data query, which rather than return the data, just returns a list of all of the possible series. So those are very useful in allowing data consumers to understand precisely what data there is, even if the cubes are very sparse. So I know this has been a problem with some data APIs in the past, in that some cubes have been very sparse, and it's very difficult to create a query that actually returns some data. So the series keys only option on the data query API is probably the simpler to implement, and that would just give users a catalog of the series that are available, irrespective of how sparse the cube is. And then perhaps for more on the more sophisticated end, the data availability API provides at a data set level again a summary on a dimension by dimension basis of precisely what values there are data for each dimension. And then if the consumer then issues the data availability query for a particular query. So for instance, if you were to set reference area to a particular country, the data availability API will then tell them precisely what other series are available, what other dimension values are available. So either of those, the series cube, the series keys only option is probably simpler to start with, but that will help effectively solve that problem with sparse cubes.
Okay. Thank you, Glenn. Anastasia, would you like to bring up any of the questions that you received in the Q&A?
Yeah, there were two questions from Christian and from Abdullah. For Christian, the question was like all the unit components are still present, but they can be grouped under the annotations. Yes, as I described, all the unit of measure components can be modeled as separate dimensions or attributes, and in the data model you have them separately. But for the presentation purpose, you can group them using the annotations. But again, it really depends on the system that you're using. The system that I was showing and describing what it can do is the Dostat suite. It has this built-in feature to automatically concatenate the components of the unit of measure. If you're using a different system, then it might not work, but it might be a good idea what could be implemented in the future. And the second question was from Abdullah about use case of the unit measure, which is quite complex. I that you received from the reporter, kilogram mole equivalent per USD 1000 constant PPP GDP. And the question was, wouldn't be it's extremely complex to go pure and split the unit of measure into all components? As I tried to explain here in my answer, data modeling is always an art of balancing, and there is no right or wrong way to do this. You really need to see what else you have in data model. If you just split it and introduce the concept that would be empty, or you would need to fix them to not applicable or to totals all the time, then of course there is no need to do that. But if the units of measure are more or less of the same complexity and they all include similar things in them, then of course you need to consider at least splitting them, or at least some components of them. And if you cannot do it at all, then perhaps you need to at least revise the wording of this unit of measure, so that end users, when they see this wording, they understand what it is about.
Thank you. Thank you, Anastasia. I have also had a number of interesting questions for the two VTL presentations. Some of them in the Q&A, but some I had myself, because usually me coming more from the SDMX side, I tend to try to find the connection to the VTL world from the SDMX side, and I see the SDMX syntax incorporating in its transformation scheme the VTL rules, and then describing the objects to which the rules are applicable. It's interesting to see that the kind of same connectivity can be envisaged totally from the opposite side, and just looking at the VTL expression first, and then plugging the objects that should be interpreted in the VTL expression from all sorts of different systems, for which SDMX is just one possible source of actually instantiating the data that goes into to the expression. But I was wondering, how do you see the, let's say, going closer to SDMX in your specific applications or in your specific endeavors? I think this question could go to both of you. And of course, please feel free to bring up any interesting questions from the Q&A that you would like to answer.
Antonio, you would like to give you so from SDMX perspective. So I'm not coming directly from an SDMX project. We have something like this in parallel with concentrate more on data production. I am a business analyst of the data collection platform, which is named Casper quite nicely. And here we have always the problem that data resides in or will go into the data lake. And then we have the need, okay, there are additional validation rules. We validate in our collection system only one submission, so one file. And after that, it's stored in the data lake. But there is more to go. So we have to cross-check, do consistency check with other data sets, with historic data. We have the need of enrichments, but mainly the validation step is something that would need to be tackled. And before we really start to do it several times and in different varieties, we came up, we said, okay, we need to close this gap. We need to have one data service that supports a variety of applications, or maybe even users that have set up their own process, use a laptop using an environment, as self-service environment on disk, that's also offered by Cloudera, and they can then use just the endpoints. We will go more and more into these data services that offers endpoints via RESTful API that can be used by applications and by users to do the job. And we see that more and more users have the ability to develop even better than we are, because we have often contractually to ask our managed vendors, managed service providers for the implementation, that they are completely able to use these APIs and even digitalize by themselves business processes. Maybe not to the large extent, but to the extent possible. And this is why we would like to offer more of these low-code or no-code development platforms beside these specific services, which are not offered as generic ones.
Most of the
Anyway,
questions.
I think we cannot hear you. Now it's better. Okay.
Okay. No, I'm trying to reply most of the questions that I think were related because they were talking about formats, SDMX 3.0 and so on. I mean, I think that I really like a lot Vtl. I think that the people working on it, they did an excellent work in many things. But one of the things I think is best is about this agnosticity, let's say. Because in the end, they took a very basic approach. Basically, the way I see it, I was not there, right? But the way I see it, that they said, okay, in the end, we are always or normally working with relational data, meaning we have a table with some columns. We need to know that some are primary keys or identifiers or dimensions, or call it what you want, and some others are not. And we need to know the names of these tables, what are the allowed values for these tables, right? So this is the core, and this is basically what SDMX is doing as well, right? So we are defining these data structures that are basically these structures. The good thing with Vtl is that they went to the basic. Basically, there is this concept that is called dataset, and then there are components that can have 3 roles, and there are scalar types, and that's it. So there are no complexities, and that is what it makes it so powerful, because then integration with a plain CSV, as long as the CSV has a header, it's done. I mean, in the end, a CSV is also a relational table in that sense. Connection to a database, if it is a relational database, if we were talking about document databases, graph databases, that would be a different story, right? But if we are talking about relational databases, the connection is there, it's for free. It's because they did chose this option to go to the basics. And this answers also with the SDMX 3.0. In the end, with the SDMX 3.0, I think that one of the main features when it comes to defining the data sets to the DSDs is the multi-measure feature, and this was already in the information model from Vtl. So that is why I would say it is already there. So yes, it is really agnostic, and I think it is very useful to use for any kind of use case beyond the SDMX and the statistical use case.
Okay. Thank you, Antonio. I think this was a very interesting discussion, and we have seen 4 very interesting presentations. Unfortunately, our time is up, and we need to regroup back to the main section. I think Marco Marini promised us to drop the link for the main session into the chat window. So everyone who would like to come back for the final closing words into the plenary session, please use the link to do so. Thank you for the presenters, and thank you for the questions, and thank you for the audience for being here with us today. Bye-bye.
Thank you. Bye.
Bye-bye.
Hello to everyone. I hope you can hear me. We are starting now with the breakout session 2 for session 5 using SDMX to modernize statistical processes and IT infrastructure. And my name is Otina Hofmeister, and I'll be chairing these sessions. We have very interesting 4 presentations of how SDMX is contributing for the modernization of the statistical processes and official statistics. I just want to mention that we will go first with all of the presentations. I see that Edgardo is still joining in. I just maybe will start with the first presentation and give you a bit of background information. So first we will start with presentation from ILO, International Labour Organization, and Shutong Ding was supposed to present the Dsd Constructor that they are using. Shutong Ding is actually the Knowledge Management Officer at Iowa Department of Statistics since 2015. Unfortunately, today he will not be able to join us, but he has sent Edgardo Grising, who will explain to us, or he will try maybe, I think that together they actually recorded the presentation, so let's see whether we will hear the recording. But for sure, Edgardo will answer all of your questions. So the Dsd Constructor is a simple standalone tool with which you can edit and create Dsd data flows and any related artifacts. So it will be quite interesting presentation. Edgardo, the floor is yours. Thank you.
Okay, thank you. I'm going to share my screen. Okay, and I have to share it with sound. This is the key aspect here. So I hope you are seeing my screen with the start of the video. Is that
yes,
okay?
Yes.
And it will launch it, and I would like somebody to tell me if also everybody is listening.
Good afternoon and good evening, everyone. I'm Shutong.
Yes.
First of all, my sincere apology for not being able to join you at this live event. This presentation is pre-recorded, and my manager, Mr. Edgar Gorizing, will be here for your questions. Before I start the presentation, I just want to ensure you I will finish it on time. At least this is one advantage I have just learned about pre-recording presentations. In this presentation, I want to share with you the latest features and functionalities we have been developed for the Dsd Constructor. I will start with a short introduction for those of you who are new to the tool. Then I will brief you the new modularized editor designed for the general SDMX artifact management. The second key feature we have implemented is the direct connections to DOSDAS Suite Data Lifecycle Manager with the direct push and pull mode. Another exciting feature in this update is the embedded translation service using Google and DeepL API. In the end, I will run a short demo to show you how the application runs in real time. So what is Dsd Constructor? Dsd Constructor is a simple standalone application which is originally designed to create and maintain Dsd and its related child artifacts. It is free to use, and we provide first-level support, and it's easy to install and update. It's a companion tool to Smart, and it has online connections to any SDMX registry, provided it's a standard. So what can Dsd Constructor do for now? The short answer is more than just DSDs. In order to fulfill the growing demands for the general SDMX artifact management, we have further expanded the constructor with the new modularized editors. So not only supporting just the DSD, we have the editors for data flow, and we also have the editors for code list, for agency scheme, concept scheme, category scheme, and content constraint. And if you already pay attention to that, all these editors follows a coherent design. So where we have the top left menu, which allows the user to switch among editors. And then we have the top right, which are the generic controllers to allow the user to either changing the languages or changing the registry. And then we have the menu for the specific editor right under the top switch buttons, where you have the import and add and edit buttons, and on the right hand side are the export features for this specific editor. And look into the specific editor we have. On the left side we have the listing panel. Once you select from any registry or you load it from a local file, and then we have the properties for those for this specific artifact, including ID, agency, version, and then we have the iTerm properties inside this specific artifact. So which in this case, if we have DSD, then we have dimension, time dimension, primary measure, attributes. And then we also have a staging area where allows user to load the extra concepts here, and then allows you to drag and drop to a specific editing panel. One important feature that we have developed for our DOSTAT suite users is the direct connection to the DLM. Using the POST API, we are allowed the users to view and add and edit structures directly inside the Dsd Constructor. And by pushing any structure messages back to the DLM, in return, this constructor will receive the same validation messages as provided from the DLM. And all the required connection inputs are the structure post URL, authentication URL, and the client ID, and of course your login credentials as admin. One interesting feature we have just developed and requested by our users was the embedded translation service. And now the constructor were able to translate names and descriptions for all the artifacts, and it provides an inline translation using Google or Dtl API. So as example, if we look at on the right hand side, the Dsd constructor will first abstract all the names and descriptions from the DSD and its all the child artifacts, including concept, co-list item. So you can also check and uncheck any of them to be included. And with that, you can later on to click on the Google Translation button to provide the translations directly here, or the Dtl translations to translate directly here. And once you click the apply, all the translations will return back to the corresponding fields inside the constructor. And it also allows the users to copy all the fields to a local sheet for the optional manual translation. Later on, they can paste back the translations. So in terms of the service specification, in order to use the Google Translation API, a Google service account specified in JSON file is required. And right now, Google provides up to 500,000 free characters per month. And the same also for Dtl. And the specification in terms of requirements is only need an API key. Now I will start the short demo. So I have my Dsd constructor open, and now it's the version 3.2.3.3. And you can see in the constructor I have all the switch buttons for the editors. So for example, I can click to the data flow, and then you can see the editors for data flow, and this is for the co-list, and they will all have the same with the listing panel and the editing panel. And all the artifact inputs here you have in the editing panel will go as the output. So just show you as example, now I want to load from a registry, let's say from a UNSD. So this will load all the artifacts from the UNSD registry. And by clicking the data flows in UNSD, and this brings you the query that is running back in the listing panel. And also if you double click any of these artifacts, and we can see this is loaded in the editing panel, and if you click the URL, and this goes to the query where we have for this editing panel. Now I want to show you how the connection to the DOM works in the Dsd constructor. So in order to do that, first of all, I have a running Docker image As you can see, there is the backend. I have the demo design, and I have the code list, and I have 9 of them. So now I want to view this inside the Dsd Constructor, and then I go to the registry, and I want to add a new registry called a localhost DLM. And then by clicking this localhost DLM, it provides all the default connections, including the structure, post URL, authentications, ID, and so on. So save that, and now I will be able to select it from my registry. So now I can view all the code list I have. As you can see, I have 9 of them right now, and if we look at in the registry, it is exactly the same. And let's say, suppose I want to change the name of the concept scheme, and how should I do for that? So I go to the concept scheme, and let's say I want to change the first one. Let's say in demo, and then this is just for demo, and then I can just push without descendant, or with descendant. That means you will have changes inside the item artifacts. So in this case, we only have to push without descendant and put the credentials, and this is once sign in and push, we have the update. So now if we go back to the tool and we refresh it, and we can see the name of the concept scheme is changed, and we can also view the changes here in the tool, and now you can see the name is also changed here for this artifact. Now I want to show you how the embedded translation service works. So in order to use that, I will go to first I have to reset everything just to have a clean start. So let's say if I want to translate the DSD, so I go here and I select the UNSD and the MDGs, for example, and then if I click this translation service button, it provides all the items, including names, descriptions for the child items, concept, code list, and code list items. If I can unselect them to be included for the translation. So right now I just include the description and the concepts for the translations. And as you can see, the Google Translation, Dtl Translation button was disabled. So in order to use these features, we have to first provide the authentications. And in order to do that, we can go to here in the registry. We need to provide a service account for the Google, and I have prepared one, and I just add it, and by clicking apply, if it's successfully connected, you will get this message. Otherwise, you will get the error with some authentication issues. It's already enabled. And also, I can show you with the Dtl translation. I have already registered free account and apply. And once it's configured, it shows you all the supported languages, and you can click OK. And now, of course, we need to add the language that we want to translate. For example, here I can add 2 languages. One is Spanish, the other one is German, and apply. So we already create the fields here, and then we want to translate them. So And as you can see in the tool, we already have the new fields for the Spanish and the German needs to be translated. So I will first, let's say, translate everything for Spanish using Google. Of course, they are translating both languages right now, and you can see it's an inline translation and it adds everything. Okay, so I'm not very happy with the translation for the German for using Google, so I can clean that, and then I use Depot. See, it's a bit than Google, but you will have all the translations provided here. So once I click apply, it will return back all the translations into the artifacts. So I have for the DSD, and you can see here, and I also have for the concepts, and you can see the translations already go into place in the concept. So that's it for the demo. And finally, I would like to thank the organizing committee and the sponsors for providing such excellent opportunities for us to present our work at this conference. Thank you.
Great. Thank you, Edgardo.
I hope you could see that in the middle I had a problem with my headset. I don't know what happened, but I hope that this did not affect the audio of the video.
No, everything was fine. Thank you very much. Maybe you stay a bit later in case we have questions. And now we continue with Jonathan Challoner. Jonathan is the community manager for the Statistical Information System Collaboration Community within the Smart Data Practices and Solutions divisions at OECD Statistics and Data Directorate. Jonathan has worked many years on data, metadata, and he has experience in the private and public sector. So today he will give us a presentation on how using multi-tenant architecture could be integrated with the SDMX information model in order to support modernization processes for official statistics. Jonathan, please, the floor is yours. Thank you.
So thank you for that introduction, and good evening, good afternoon, wherever you are. I hope you can hear me and see my slides okay. Perfect.
Yes. Yes.
So yes, as you said, I'm going to talk about delivering XDMX tools through Devsecops, and I'll explain what that is about. So maybe first, I want to talk about disruptive technology. And if you think about disruptive technology, probably things that come to mind are probably things like AI, 3D printing, blockchain, virtual reality, and sort of Internet of Things. So these are things that probably come to your mind when you think of disruptive technology. In software development, though, disruption has been happening in many areas and over many years, but container technology, and this is something which is at the heart of what we're doing here at the SICC, and also in regards to Devsecops, is really didn't start to emerge until around 2013, although it didn't really sort of become mainstream until much later. And as you can see from this sort of image here, the timeline of how it evolved over time and the different players that were involved, none of these, of course, are statistical organizations, as you can see. From a statistical organization point of view, I mean, if you think about disruption, big data hit, and official statistics was really, I remember being in many forums where we were, organizations were scrambling and wondering what to do with this and how to deal with it, and worried about being left behind and maybe becoming irrelevant. But today, actually, big data is being embraced a lot by organizations, as we see, and some presentations here also in the previous sessions around tapping into new data sources, mainstreaming practices and processes in different data science techniques, such as machine learning. But what if the same could be done for the IT landscape for official statistics? So the main topic I want to talk about is the Devsecops part. So in Devsecops, we in the SICC model, at least, it's an open source delivery model. And this evolves around continuous integration. So this is the practice of where you continuously develop the software, constant code checking, ensuring nothing is broken in that chain, and rigorous sort of processes in place that a lot of this is automated. And then continuous delivery and deployment. This is very important to think about this in how do we approach and manage that release of the project and automate that to gain maximum efficiency. We don't want to spend hours having to build releases and deploy releases and support releases. So as I said, this is the main topic in my presentation, the overall operational mechanism that we refer to as this is DevSecOps. So this is development, security, and the IT operations. And this is very much the sort of model that we're applying in our community. And basically the default in many software development operations today that you see. So in statistics, however, this is not something that is very commonplace, and we've seen also in our community even some resistance and some difficulties to actually get traction in this area. So our community is the SICC community. It's currently 15 organizations today. You can see their logos on the screen here. Very diverse community, but ultimately we're all driven by the same needs and around the same strategy, which is really focusing on delivering solutions to common problems and co-investment model and co-innovation model around this. So a key part of what we deliver is the .stat suite. You've probably heard a number of presentations. Shutai in the last presentation referred to .stat suite as well that they're using in ILO. And this is a modular architecture that's flexible, it's cloud ready, scalable, and high performant. These are very important aspects if you think about, if we go back to what we talked about in the previous slides about automation and efficient delivery of software. And this is open source, so these are key aspects. And of course, it's native XDMX, so we wouldn't be talking about it if we weren't delivering an XDMX tool. It's made of 3 components: the .stat Data Explorer, the Data Lifecycle Manager, and the .stat Core. It's supporting global initiatives, so our colleagues at the International Labour Organization are using it to support their work in labour market information systems in more than 18 countries, where .stat is at the core of this, being deployed and facilitating for the dissemination and reporting of labour market statistics via XDMX web services. It's also supporting other initiatives, and on Tuesday you saw a presentation around CamStat by the National Institute of Statistics of Cambodia and our colleagues from the United Nations Statistics Division. And this, we supported them and a number of partners in deploying this as a service on the global platform infrastructure. And this is allowing for a low-cost way to actually run .stat as a service in the cloud for countries that wish to take that route and may not necessarily have the capacity to deal with the technical issues that may arise internally. So it's very important to think about this and the flexibility of deploying this in a DevSecOps way is the multi-tenant architecture. So it's built in a way that can support this. And again, if I go back to the previous example around the UN Global Platform deployment, this will allow you to scale up. It will allow organizations that want to take that route to not build complex infrastructures and worry about all the security plans that have to be dealt with. Everything is hosted in the cloud. Everything is maintained centrally. There's a distribution of services. There's scalability there. There's a way to actually integrate and build additional tenants. So this is additional instances of .stat, if you like. And the chain, the Devsecops chain automatically is maintained, and instances are updated seamlessly with the latest versions. And of course, a big part of this is costs and resources are minimized. As a community, we're supporting, so we have a governance model that supports this and these different initiatives to emerge. So as I mentioned, we're enabling sectorial sort of efforts to be realized, but also at national level, a regional level, through a tiered model that members aren't necessarily part of the core group of 15 that are investing continuously in this project, but are supporting it through different ways and supporting members, say, in a region, say in Asia. Also, it's allowed for a technology partner program to emerge and for them to offer services to make it easily deployable and hosting and support countries that, again, may not necessarily have the capacity to join the core group of organizations that are maintaining this project. It's also supporting the modernization of the fish statistics agenda. So this is a key part of what we support through the standardization of the data flows. And you saw the presentation earlier today from Jens Dosse around how important it is to model data in the right way, and good, solid data modeling practices according to XDMX best practice is vitally important for this to succeed. Also supporting capacity building efforts. So there's been a big call for, and I think a lot of mention of a potential XDMX academy. So we're building a .stat academy, which is really focusing first and foremost on the .stat suite. Of course, there'll be aspects of that will support the data producers. So these are the people who are modeling the data, if you like, and producing the data to disseminate. But the idea here is actually to sort of maybe leverage these things and allow for something like an XDMX academy to emerge later. One key success factor of this of our Devsecops chain has been harnessing of container technologies. So this is a very important thing. There was a lot of mention, about complexity of deployments and things like this, and ease of deployments, and the way that this is now being deployed, and our members, including the Federal Competitive Statistical Center, provided feedback to say actually now they have everything set up. The updates of their instance is actually minutes. So it's a very efficient way. Once you've got over that sort of initial constraint of understanding what this is about and actually setting up all your flows correctly, this can be a very efficient and fast way of deploying XDMX tools. So to finish, really, if we think about big data, most statistical organizations were very maybe not scared, but wondering what to do here. And I think we embraced it, and we took the opportunity to sort of innovate around big data. And I think there's an opportunity here where we can actually do the same for technologies that allow us to efficiently develop and support and deliver tools such as the .stat suite for XDMX use. So I'll stop there. Thank you.
Thank you, Jonathan, and thank you for keeping the 15 minutes. So we don't lose time and we continue with the third presentation, and this will be presented by Frank Cotton. Frank is a scientific advisor to the Director of Information Systems at the French National Statistical Institute, and his main field of work includes statistical metadata, international cooperation, model standards, data science, computer science, and enterprise architecture. So Frank will present was the Interstat project, which aims to develop a framework to allow interoperability between national statistical portals and the European data portal, and of course, interoperability with SDMX information model. So Frank, the floor is yours. Thank you.
Okay, thank you, Zlatina. I hope you can hear me and see my slides. And
yes, we can hear
maybe
you
my face, but that's less important. So yes, I'm here for the Interstat project, which is actually a project which is, as you can see in the bottom of this slide, co-financed by the Connecting Europe facility of the EU. So that's a quite big program for developing shareable components. Like, for example, one of the best known is the European Data Portal, but there is also another one of these building blocks, which is called the Context Broker. And this is the one I'm going to speak about. So the Interstat project itself, the overall objective, you can have it on the screen there. It's to develop a framework to allow the interoperability between national statistical portal and the European data portal. And this is done by using technical assets, common ontology, and deploying cross-border services reusing those portals and data set from those portals. That's a general objective. The project consortium, as you can see here, is made up of four organizations. Engineering is a very big IT company from Italy. Fireware Foundation, you may know, is a very big foundation with very big IT companies. So think Atos, think Telefonica, think NEC, so not startups. And the providers, the data providers are INSEE, so that's the French Statistical Institute that I work for, and ISTAT, which is the Italian Statistical Institute. So the objectives of Interstat I've listed then on these slides. I won't go through every one, but basically it's to enable interoperability, as we say, to provide standards and tools and to provide a visualization and to develop pilots in order to exemplify all these. The main objectives that I'm going to talk about, and the one that is why we are here today, is to provide a uniform technical interface for reuse of statistical information through the adoption of the CEF context broker building block and the implementation of ETSI and GSIL API specification. So that's a lot of acronym, but I'm going to explain what it is in the next slides. First of all, I would like to list the different pilot projects that we have in Interstat in order to test our different developments. So the one that is really of concern here is the last one, which is in bold already. That's the one about supporting environment policy. And in this case, we try to develop a cross-border service, so between Italy and France, of course, that disseminate both different types of information, actually. So that's information about air pollution, which is collected through sensor throughout the Europe in general, but in particular in Italy and France. And that's basically sensor data. And the other type of information is statistical data, and that's what we're here for, which is about demographic characterization of cities and areas in general. So that's census data, to do it short, but it's statistical data which is used and with this air pollution data. So what's this context broker thing? Well, basically, it's the idea is to disseminate what is called context information. So context information in IT has a very precise meaning. It means information which is aware of the context of the information consumer. So we are disseminating through the context broker information which is aware, for example, of the context of the user, the consumer of information regarding time, regarding location, regarding some preferences, for example. So that's the idea of this context broker. And the context broker is really at the heart of all that is dissemination of information, like for smart cities, smart cars, smart, well, you name it, but every smart things that you can find nowadays is using this type of context information. Well, basically, that's another more fancy representation of the context broker. You see that there are different types of information providers or information consumers that are subscribed to the context broker and that publish or consume some information, contextualized information. So when you want to disseminate information through the context broker, actually you have to present this information in a specific data model, and that is called the smart data model. And there is actually a very nice ecosystem for building this model, which you can find at smartdatamodels.org. And I invite you to browse to this website. So you can find tools, for example, for creating a smart data models, which corresponds to the information that you want to disseminate through the context broker. All is based on standard tools and open source tools like Git, for example, GitHub. So you have the assurance of having a complete visibility of the different model, and in particular to be able to reuse elements from already existing smart models. There are something like 600 smart models that exist actually. So that's a very nice ecosystem, and I invite you to see it. Basically, the smart data models that exist currently cover lots of different topics or different domains. So you have some of them here. So smart water, for example, smart cities that I already mentioned, smart environment, etc., smart energy. And for each of these domains, you may have one or several smart models. So basically what we're trying here, if we want to get back to the objective that I mentioned in the beginning, is something like building a smart statistics smart model. That's the idea. The smart models themselves are based on core information models, just applications of this core information model. And this information model is specified by a standard which is called NGSI-LD. So I'm not very sure what NGSI is for, but I'm sure that LD is for link data because it's an RDF model. It's published by the European Organization of Standardization, which is called ETSI. The last version, as you can see, is quite recent. And it's the de facto standard for context information, so smart cities, Internet of Things, etc., etc. And the information model itself is actually organized in, I would say, an onion structure. At the core, you have a very, very high-level model, which is, for those who know this model, it's the property graph model, but it's something a bit more complicated than RDF, but not much more complicated. And it translates very well to RDF. And then around that, you have a simple cross-domain ontology, not a big one. There are like 15 or 20 terms in that that define basic attributes or classes that can be reused in the smart models themselves. And so at the third layer, based on those two inner layers, you can build the specific model, the smart models, using the NGSI-LD specification. Okay, so if we get back to our problem statement, the overall objective, as I said, is to publish statistical data through the context broker. And when you think of it, it basically boils down to the question of interoperability between the NGSI-LD model and statistical models. If we have interoperability between those kinds of models, we will be easily capable of publishing statistical data through the context broker and benefit from all the features of the context broker. For example, the possibility to mix statistical data with other contextual data, the possibility to use the API, because NGS-ILD also specifies an API, and the API, of course, is made for consuming and producing context information, but it also covers things like notification or subscriptions and things like that, which are very important for this type of information. And so basically, the question, as I said, is to study the interoperability between the NGS-ILD model and some statistical models, and in particular, the SDMX information model, the data part, but also the metadata part, because we, of course, as statisticians, we know that data without metadata doesn't mean anything. So we want also to disseminate at least the structural metadata, but hopefully more than that, also some kind of quality data, for example, or some kind of descriptive metadata. Starting from the information model, we can then generalize to other kinds of statistical models. For example, one candidate would be the VTL data model. We spoke of VTL in the previous session. VTL has its own model, which is a bit simpler than the SDMX information model. And if we go beyond that, we can think of another information model for statistics, which is called the cross-domain integration model, and which covers different types of data. It's a bit complex. It's way more complex than the SDMX information model, but it covers different kinds of data. And so this question of interoperability within the Interstat project we are studying, we have begun to study it on the basis of this supporting environment policy that I was mentioning at the beginning. So we are really at the start of the path here. And I invite you, if you are interested, to see what we are doing and to contribute maybe, to contact us. The data that we have for the SEP pilot are very well specified. That's why we chose that. Air quality data is very well specified by the European Environment Agency. It's very coherent throughout Europe. The data and the metadata is very well specified. The code lists are expressed as costs and everything. So it's very good. And same for the demographic data, sorry. We are using the Census Hub data models and metadata, and all this is in European regulation. So it's very, very, very well specified. And for the air quality data, as I said, it's sensor data. And for the demographic data, it's actually dimensional data. So it's expressed in SDMX, or in this case, actually in the RDF declination of SDMX model, which is called data cube, because as I said, NGS-ILD is RDF model. So you can't read that. I'm pretty aware of that, but it's just to show you that we have worked on the first results of the translation of the census data, the structured data definition into NGS-ILD, and that's pretty straightforward. It raised a few questions regarding the NGS-ILD, but these have been addressed, and so now we are pretty confident with the idea that we will have an automatic procedure for translating statistical data definition, structured data definition, sorry, into NGS-ILD. The question is, do we have to have one data model for each of the data structure definitions, or can we have procedures, automated procedures at the model level? So translating the information model from SDMX directly in NGS-ILD, which would be very easy for every DSD, every instance of DSD, we would have automatic procedures for translating the data into NGS-ILD. So that's it, we are here. So the idea, as I said, is to automate translation of the SDMX data into NGS-ILD. We're pretty good on the path here. And then to deal with the metadata part, which is not dealt with currently. We just had studied the DSD part. Some updates of the model specification, the NGS-ILD model specification have been identified and will be fueled into the procedure of standardization of NGS-ILD. And then the next step would be, as I said, to generalize to other statistical models. And then maybe, hopefully, if we have the time, to link to other useful models. And for example, an example that we have in mind is the semantic sensor network ontology, which is very well adapted for the air quality data. And I think that's all for me. I hope I was not too long, and I'm ready to take questions. Thank you.
Thank you, Frank. So we continue, maybe we go back to the questions after the last presentation, then we will address all of the questions also that are in the chat. So we continue with the last presentation, and also in the context of the launching of SDMX 3.0, maybe the lessons learned from Michal Bolesini will be important, because of course interoperability between the different SDMX standards is very important. So Michal is coming from the National Central Bank of Slovakia, and he's an IT system specialist at the Statistics Department. And his key responsibility is to develop different methodology to collect, transform, and load data from various sources into different locations within the bank. Very often, different institutions are using different formats and using different infrastructure to hold the data. So he's working with this. So he will explain to us what are the lessons learned from the migration from GESMAS to SDMX ML on the side of the Central Bank of Slovakia. Thank you, Michal. The floor is yours.
Thank you. I was Latina for introduction. Can you hear me, see me? And I cannot share screen, so can somebody just finish the viewing?
We still see the presentation from Frank. Yes, I think most probably now you can share.
Yeah, sorry.
Yeah, can you see my presentation right now?
Yes. We see the
Thank
presentation
you.
and we hear you well.
Yeah. So in my presentation, I would like to introduce how we migrate from old format, which is GESMAS, to a new format SDMX. For the people that might not know, GESMAS is a format that was used before SDMX. It was really hard to use this file system because it's very hard to validate. There was almost no data structures, and it was really messy. So when somebody looked at the GESMAS file, it was almost impossible to see what data are from. And this presentation will not be about how we wrote the code. It was rather about the architecture overview, what steps we did and what steps was mistake, and what we learned from these lessons. So what was the motivation? It was because European Central Bank decided to end support of GESMAS until end of this year. Also, it will be great PR or HR reputation that we are using open source technologies, because as was also mentioned in the previous presentations, statistical companies are not using big data, are not that open. So we'd like to just use this as a showcase that it's possible to use open source technologies and build software on the top of them. So the first step was you have to analyze the business requirements. It was, I guess, typical project management lifecycle. When you analyze business requirements, then you consider the scope of the project, decide technology stack, then you should try to find the open source technologies that you would like to use. And of course, you have to reconsider the scope of the project, because this takes a lot of time. And while from analyzing requirements to analyzing open source technologies, it's a lot of months. So people will come to you every time and would like to ask to add something more to your project and extend scope. So first scope was only migrate GESMAS files to SDMX, but also then we decided to switch the way how we receive and send data from European Central Bank, because currently it's only using file share adapter when you only upload a file to some remote disk, and all the metadata of this file is provided by file name. So it's not that good, because it's very hard to trace logs and you don't know who uploaded the file, and it's very easy to just fake the file. And also we decided, because alongside with this project was a new project building our national a new website for our company. So we decided to try to find a way how to visualize SDMX files and put there into our database. Technologies that we decided to use for ETL and scheduling, it was Apache Airflow. For platform, it was Red Hat OpenShift, Kubernetes, but if Red Hat OpenShift is the software we are currently using because our IT department already have it. And for login, it's like really classical Trio, Logstash, Elastic, and Kibana. I guess Apache Airflow is the best thing for this project because it's very easy to maintain. I think they're missing some user interface where you can just easy click all the requirements or easy click some extraction jobs. For example, when you would like to pull some data from Google Sheets, and other ETL tools already have UI where you just put Google Sheet URL and it downloads automatically. But once you write all the libraries and all the tools, it's very easy to use and reuse. So how we decided to build ETL? Firstly, we decided to execute ETL on the Airflow server, which was wrong approach. It was because sometimes it might happen that we update some dependency on an Airflow server that we will use in our ETL. However, it will destroy our ETL server because there will be some dependency conflict. So later we decided to execute all the transformation in our private Docker container, where our all applications was stored, as I mentioned before, like some Google Sheet tools and everything else. But also it's better approach. However, there might be problems with executing when there is Docker in Docker, because once it's running in Kubernetes, it's a Docker, so it's very hard to build Docker in Docker. So this might be the technical debt in future. For now, it's okay because we are transferring only small files, but in future it might cause some problems. So this is a overview how the Airflow looks like and how the flow is when we just load some CSV, set up instance in a Postgre. When we put data from that CSV file, also we can load some external tables and validate it. And then we transform it and just push it to ECB. We are using XD connector. Also, we can process in batch when we can load data from multiple sources and just attach some disk, the same disk file. For example, some CSV files will be all stored in one disk, and then this create SDMX batch will just transform them to SDMX, validate, process logs to our Kibana, and then push data if they are valid to European Central Bank. When we were deciding which converter we should use, firstly we decided to develop one in-house, which was obviously wrong approach. It was time consuming and it brings me a lot of frustration. So then we decided to find another one that is already prepared and which is open source. So I tried to find something on GitHub where is 237 repositories, but none of them was really suitable for me. So I tried to find something on SDMX website, and we found SDMX converter from Eurostat, which works really well. It's well documented, and it also provides command line interface. So thanks to it, you can process data in batch. And obviously it works on Windows and Linux-like systems, so you can use it in Docker containers. So for how we are working on it now, we just deployed our Airflow to OpenShift cluster. Our data pipelines works well. We are converting SMES to SDMX. We can validate our data that was provided, and we are finishing the ECB connector. Future plans. We would like to provide some or implement continuous integration, because currently data pipelines are just hard-coded in Docker images. So we would like to use Git or some version system where we can just put new source code and it will be deployed automatically. Also, to avoid problem with Docker in Docker, we would like to when a new transformation will be executed, new pod on OpenShift will be scaled. Also, message queue in a communication with European Central Bank would be implement it because currently we are using file share adapter, as I was mentioned. Next step would be stop generating GetMess and use directly SDMX as an output, because currently is only some Excel files with macros. When we download it, or putting many data all together and generating GetMess out of it. Later, I would like to publish all this source code as an open source project to GitLab. And this is very high level to do cross validation, because we have another data from another data sources. So we would like to validate the data we received from European Central Bank with our data from external sources and validate if everything is okay. So what are the key takeaways from this project? It was executing transformation inside containers is not always a good way. Also, I wouldn't spend a lot of that amount of time on bringing new solution, because reinventing wheel is not worth it. However, open source technologies is worth it, as we can see that we built this technology on open source technologies. That's all from my side. Thank you. If you would have any question, there is QA that you can ask questions, or you can write me an email, and I will be more than happy to answer all of your questions. Thank you.
Thank you, Michał. And we finished really on time with all the presentations. So thanks to all of the presenters that you kept the time frame while you were speaking. And I see that actually in the Q&A we have 4 questions. I think one was answered already, but maybe we start with the first presentation. It's a question to Edgardo. The Google Translate feature is very neat. It's a question from Eric from OECD. But he would like to know how you could measure how reliable it is based on your expert translators' feedback. So were you able to measure it?
No, not yet. But it's a very good question. And yes, we will try to. Actually, we finish with the testing the feature very, very close to the global conference, and we wanted to present the new feature here. What I can say that if from my personal experience, basically translating to Spanish, because we have 3 projects in Latin America, and also because it's the language I can judge about the quality, at least my Spanish. And I prefer DeepL rather than Google Translate, although Google Translate has much more languages than DeepL and is faster. I think that the quality of translation, at least to Spanish, is better with DeepL. And it also has a glossary feature that you can enrich the dictionary as you use it more. It translates closer to your language, that I don't know if it's good or bad, but at least you get familiar with the translation. But yes, we are going to try to do some benchmarking with translators, let's say.
There is another question, Edgardo, for the Dsd Constructor from Hungary. So Eva is asking, the Dsd Constructor is good for the data structure describing what is ordered by Eurostat, or we can use to create our own DSD. So the question is whether it can be used to create own DSD or it's only for existing ones.
Both. You can create any of the artifacts that Shutong presentation showed, not only DSDs, but also all the data flows, code list, item schemes, category schemes. Everything can be created from scratch. Everything can be imported from files or can be fetched from any SDMX 2.1 compatible web service. So the demo that Shutong did, he interacted with the UNSD registry and also with the Dostat Suite DLM entry point. In the case of Dostat Suite, because we use it in our LMIS, we also implemented the push of not only the get, not only fetching the artifact, but also pushing the artifact directly. In any case, if you don't have this capacity with another registry, you can generate files. So the artifacts can be exported into SDMX files separate artifacts or integrated in a single message. So all the possibilities are covered. And if you have new demands, we are always eager for requests for new features to add to the product.
This is maybe also connected with the question that I had, whether the tool is the interoperability of the tool with other existing tools. I was wondering, but it's easy to integrate it. But you gave an example, actually already 2 examples where the tool was taken into production without an issue, right?
It's a desktop tool, so it integrates with any web service or any application through the web service. As I mentioned, the case of the pushing the information so far is only possible with DOS.NET Suite DLM, but one of the improvements after SDMX 3.0 is available will be to implement the now standard way of dealing with structural metadata that is now standard in SDMX 3.0. So that will make the tool be able to put data, to put artifacts in any SDMX 3.0 registry.
Just out of curiosity, do you have notifications there too working, or you did not consider? In case, for example, I update a data structure definition, can the tool notify, or in a way, in case a change is done? Or you're relying?
No, we haven't gone so far. It's a good idea. I take note.
Okay, good. Thank you. We continue with the rest of the questions. And the next one goes to Jonathan. So Jonathan, it's again Eric from OECD. He's asking that you mention organizations who are literate in the container technology, such as Docker, and are able to deploy solutions like .stat smoothly. But what about an organization who has no such skills, or with a pushback from their IT? How do you see them transition to this modern approach of deploying and maintaining applications?
Thank you for the question. Yeah, it's indeed, it can seem quite daunting to start. There are many challenges to get over, especially in regards to security and in sort of traditional IT sort of environments, I would say. Teams need to be upskilled, of course. That's an important part. And you heard a lot about, the need to learn even about XDMX is important, and data modeling. I mean, in the way that tools are managed as well, this is another thing. But only those who want to deploy it. So these are the people who are managing it and deployment of it. Today, container technologies such as Docker, we heard in the last presentation, Docker mentioned, that outside official statistics, it's quite widespread, and it has been for some time. And there are a huge number of resources available and trainings even that are available. Recently, for example, our colleagues and community member from the Institute of National Statistics of Tunisia undertook a Devsecops training. And this is to allow them to support the deployment and maintenance of their .stat suite instance, but also with a future objective to be able to contribute to the source code. So this is actually success, and the training here will be actually reused in the context of the .stat Academy that we will launch in the very near future, which will provide more trainings on this subject as well. But I think just to finish, maybe the last, it's very important to not think about the complexity of this. It's rather, you should look at it on the other side, actually the benefits of adopting technologies and approaches such as this. It far outweighs the sort of learning curve that you're needed. And often in organizations, you will find at least one willing sort of person to experiment and push this agenda.
Yes, there was another question from Eric that you answered in the chat, but I will ask it also here so you can elaborate. So the ones that did not read, maybe they can also learn something. So Eric mentions that you did not elaborate on the SEC or the security component of Devsecops. So if you can a bit elaborate on this. You're muted. Just.
Sorry. Yeah, as I said in the response, it's really important to very early in the project as well. I mean, this is something we put in place and discussed with your InfoSec teams, and to think about the right processes that will allow you to actually automate and release software that is sort of continuously checked for vulnerabilities, and also deploying penetration tests as well. And this is something most organizations will do anyway, regardless. But as a software sort of production line, if you like, it's important to automate these checks. And we've done this through specific tools that allow to check the source code. We minimize who can actually commit to the master branch. So this is the master branch in the source code is where the source code becomes live and deployable. And this is minimized in who can actually do this and merge those commits as well. And so this is very important to maintain this. And when you think about doing big releases, again, to think about potentially new penetration tests or new environments that you want to deploy, to continuously maintain this security. Security evolves, so we have to be on top of that by constantly sort of testing and evolving with it.
Thanks a lot. And I think we don't have any more questions, but I have a question for Frank and a question from Michal. So Frank, it was really interesting presentation, and I know that many different international organizations are using different information models. So I was wondering whether it's possible to generalize on other statistical information models like XBRL. I know that you gave an example of DDI, but in the central banking, we're using, for example, XBRL, and internally we always try to link the different standards. So I was wondering whether you had some experience.
Well, actually, we didn't consider XBRL right now, but it's a good idea. You may want to check in the existing model, because there's a smart finance model somewhere. So you may want to check if there's not already a transcription of the XBRL model in the smart model, which would be nice. But yeah, for us, we basically limited ourselves for now to statistical models. So we thought of SDMX, we thought of VTL, of course, and we thought of DDI, CDI, but not of XBRL. So that's probably a next step. I'm taking note of the idea.
Okay, and I have another question. I was wondering, because you were showing also these translations from SDMX to NGSI. I see also Edgardo wrote what it means, next generation search interfaces, and LD stands for linked data. So you were showing this one directional interoperability, and I was wondering whether you looked also at both directions.
For now, we're looking to disseminate open statistical data. So the main direction we want to explore is really from SDM, from the SDMX statistical data to the NGSI LD model. But we have in mind somewhere to be able to consume also information from NGSI LD. But that's not at the same stage of the process, of the statistical process. For now, what we are concerned with is really to disseminate open statistical data through the context broker. Yes,
I was thinking that maybe you can use it to link also the different standards if you have two-directional link. But it's very
yeah. But it's the field is very wide, so we have to start somewhere.
But thanks for your presentation. It's very interesting, and for sure ECB will be also looking at this because we are looking also to disseminating data into the European data portal. So it's a very interesting presentation. Thanks a lot. And I have a question for Michal. I see that no one is brave from the audience to ask, but I find the presentation from Michal also quite interesting in the context also of the introduction of SDMX 3.0, since we have, of course, a new version of the standard, and it's, I mean, most probably not immediately, but in a few years' time, people will start moving from SDMX 2.1, 2.0 into SDMX 3.0. So I was wondering whether how you will take the same steps that you currently do in case you have to move to SDMX 3.0 in the future.
Well, it's a good question, but I do think once you are using SDMX 2.1, it's not that hard to just move on to SDMX 3.0 because the structure and everything is almost the same. So I guess the hard step was to move from GuessNest to SDMX, but upgrading to SDMX wouldn't be that hard. But if you are prepared, if you are prepared for data structure definitions, code lists, and everything else.
Yes. And maybe just to give some feeling of how much work it was, the whole process, how many people were involved and how long it took for you?
It was only me because, yeah, because firstly, I thought it will be really easy to just build a platform on the top of open source technology because there are really big communities. So I thought that I can just ask community if there will be some problem. But it wasn't. It was very hard to just find some information, mainly using Kubernetes because it was the first time I was using it. I had previous knowledge of Docker, but Kubernetes was a bit different, and it all started in January. And I hope we can finish it in this year.
Yes, it's a good news for others that have to do this. So they need one person in 1 year time.
Yeah.
Yes, in the best case. But thanks a lot. I don't see any other questions now in the Q&A. So in case no one wants to ask something, our panelists, then maybe it's time. Actually, we are closing very much on time. I heard that the other breakout room, they had some technical issues, so they're a bit late. So in case you're interested to hear maybe their Q&A, you can join now. Thanks a lot for the panelists. Thanks a lot for all of the attendees. I hope that it was interesting for you. And I hope that you join us again tomorrow when we will be having the closing of the conference. And I wish you a nice day and nice evening. See you. Thank you.
Thank you. Bye.
Bye-bye.
Bye, everybody.